Welcome to Database Development Lecture 26, Beyond Relational Data and Object Relational Databases. So, firstly, not tomorrow, and we are now in the object relational models, and tomorrow we are going to talk about the data warehousing and data mining. So firstly, what is object relational programming? We have the classes, we have the inheritances, we have the identity states, behaviors, and the encapsulation, the inheritance, and polymorphism. It is worth noticing that the same identity is not equal to the same state. But how about the relational databases? We have the relationship, the collection of tuples, the same attributes, and the tuple is just the state with no behavior. And the values are extracted by updating a high-level queries rather than calling on the tuples. This is the key thing, that the same identity is the same state, okay? Because we are referring to some state, we are referring to some tuples through this value. Therefore, there is no we seldom query things through their references. And the impedance in the physical world is just like the resistance or something like that. And the mismatch is just like the objects and relationships cannot objects and tuples, procedure and declarative and the data. This is like different words having trouble communicating through each other, and so it's like the impedance mismatch, and the streamless application takes the resources, which means that we need to learn more and negotiate between them. So the object-orientational relational database comes into play, which extends the object-oriented programming technology. So the person string, persons and get name, and maybe the program, students. Yeah, so. What is the idea here? The idea is to add the persistence of the objects. The database takes care of the storing objects in the memory and concurrency control and transaction and both. The sharing of the objects between applications is possible. It's just like, so what is the persistence of the object? We think of it's the database takes of storing the objects, sharing of persistence of the object, right? And in the early database management system, we have the class student, a string name, int number, string program, and a vector students. And we have another external data storage file, which is like Anna, and we can do the pass to get the values from this external data file. So which is basically the database management system of the 1890s based on these ideas. So the disadvantage is hard to program, it's not very advanced, and it's hard to add new files because sometimes, just like adding a new attribute. And the object-oriented database management system surged in the early 90s because it's today. Originally, it thought to gain a big market, just like what artificial intelligence get very hit. But now it's relatively small market and only used in some kind of CAD design, solid work design. There are many problems here, where the application design is tied too closely to the database design, and there's no declarative querying languages, and early on there's no standard, many design errors. Many of the ideas are found in the object relational databases. But the application design tied to the database design. We have the common refactor code, make small improvements without changing the behavior, hard to do with the object-oriented databases, make changes to all objects, must check that all databases are made correctly. Apart from that, we have no declarative querying language. The SQL query states what you want, but not how to do it. There are a lot of optimizations. There exists some declarative-like transformation in the general with object-oriented programming language compilers, and it's much harder to do automatically because more options have the satisfiers. and there is no early standard. For example, that the early standard is in the 93 called ODMG, and most like Java and C++. So the difference is that each object will have an object ID. The object can be given a persistent name. So the persistence is just like something that extends for long. And there are two types of inheritance, which is extend and implements. This is a typo, right? This is a typo. It is implements. And it is the first to use factory objects. What is a factory object? And the object relational databases, we have the object relational databases attempt to get the best of the object-oriented model is content data type, and the relational model is high-level query languages. The object-oriented features in SQL 9.9 above is possible to define classes, inheritance, and polymorphism with other features. But still, an SQL dialect, where dialect means dominate, I think. Most of the commercial differ from the object relational features. So we can do some user-defined types. For example, it's like the main use as the attribute type and the row as the row type. And we can define a user-defined language without method. Create a type T as the primary type. Create a type T as the attribute declaration. Create type address as street char, city char 20. And just like the create types address as, and the user-defined language as attribute types. The user-defined language can be used as the attribute type. For example, we can create type address as street char 20, street char 50, city char 20. Create table student as name char, so address. And the user-defined language as row types. We can have a create table name as type name, create table student as student, and this is originally done in the SQL. But now we can have create type student as the first name, last name, and student ID. We can create a relationship with one column whose tuples are objects of the type student. And this relationship is just called students. So apart from that, we have the queries. To query the object, we just use the normal SQL standards like select all from students as aliasing. I think this is a typo in the PowerPoint here. Apart from that, we have the observer method. It's just what if we only want the values, not the whole tuples. We can create. We can use select s dot first name parentheses. So, and originally you can use s dot the first name without the parentheses from the student's s. And we can add in the method to the user-defined user-defined one is just like originally you can see the create type address as street char city, and we can add some method signature as the signature as the method house number returns char, and we can create a method house number returns char, find for each address to begin. This is how we are going to find this method. And apart from that, we have the inheritance, which is implemented via a table inheritance, which is keyword under. Create a table cities, name, text, population float, altitude int, and the table capital is under city, state, charts. Just some references that are essential for the object-oriented model to see that attribute A is a reference to the object type B in relation R. A ref T scope R. For example, is a create table students name chart 50 program ref program scope program. And how do we generate these references? We can say ref is the program ID system generated. Create a table program ref is the program ID system generated name chart 50. So this is the thing. Hi, and this program, it can be anything. I can say this program this proc is just the attribute A, so it's just the attribute within the student, right? And the ref program is this program. It is this program. This is T, and this is this program. We can give you an example. It's like honor program, and this program Z is every program, and every program, and we can see this ref is program ID. Program ID is what is the program ID here? 就总而言之啊，就是说这个我们就可以理解这个 T 啊，这个 T 就是这个 T 就是这个叫什么system program， 不这个 T 啊，这个 T 相当于那个你的 honor， 你就是荣誉学位，这个是全部的学位，这个是你就随便给你 student 起个名 ，student 的一个 attribute 一个名，但是我不知道这个 program ID。ref is program， 反正这个永远是要 type，ref 一定是 type，ref is program ID， 这个 program ID 是，就这个是就定义了一个这个，那你要这个 program ID 的用处干什么？就是这里面这个 program 就是定义的这个 program 它有什么样的一些就是特征啊之类的。接下来我 talk about how to reference the feature. We are going to use the this sign students dash and ending bookmark, and that will return the attributes and dereference to A. Dereference 就是拿值啊，好吧啊。Other features, various other features that have not been, for example, generator, mutator, ordering, and we can read the documentation of PostgreSQL, Oracle, object relational database management provide much flexibility and solve the impedance and mismatch problem. And there are many advantages, disadvantages, but using some areas, object is still trying to combine the best of the object relational databases and the traditional relational database. Okay, that's all today. Thank you very much. Welcome comments and subscription.